The Engineering of Large Software Systems, Week 4, CMMI, an example of a process improvement model. We continue to look at process as a key environmental factor. This week we will look at a specific instance of model-based process improvement, Capability Maturity Model Integration, or CMMI. The idea is not to make you experts. There are plenty of high-priced consultants out there for that, but to understand the value and pitfalls using a real model rather than abstract discussion. Please understand that I am not proposing CMMI as the way to improve your processes. In fact, I am essentially agnostic toward CMMI's value, but we'll discuss this later. CMMI is a good example to use, and one that I had a hand in building. Model-based process improvement involves the use of a structured framework to guide the improvement of an organization's processes and, like any kind of PI, is aimed at increasing the capability of work processes. Essentially, process capability is the inherent ability of a process to produce planned results. As the capability of a process increases, it becomes predictable and measurable, and the most significant causes of poor quality and productivity are controlled or eliminated. By steadily improving its process capability, an organization matures. In large software system projects, the project is generally considered the organization, even though it may report to a higher authority that may own some of the processes required. CMMI comprises a framework for coordinating process improvement efforts across an enterprise and measuring and monitoring the status of those efforts. It provides a basis for benchmarking the capability of individual processes and the maturity of overall organizational process. Periodic CMMI appraisals can provide a broad-brush scorecard indicating where process strengths and weaknesses exist and which areas deserve attention in future process improvement planning. The CMMI product suite contains an enormous amount of information and guidance to help an organization improve its processes. Essentially, CMMI models contain two kinds of materials: materials to help evaluate and improve the content of your managerial, technical, and support processes, materials to help you improve process performance. Let's look at the process content first. CMMI provides guidance for your managerial processes. For example, you should establish and maintain a plan for managing your work and make sure everyone involved is committed to performing and supporting the plan. An example of CMMI guidance on technical matters includes ways to develop, derive, and manage requirements, and to develop technical solutions that meet those requirements. Support processes for technical and managerial activities are also addressed as part of CMMI. Managing the versions and configurations of intermediate work products, as well as end products and services, fall within this category. Once processes have been established, improving them becomes a key goal. The improvement information in CMMI models includes ways to get your organization to focus on defining and following its own processes. Processes become more capable when they are standardized across the organization, and their performance is monitored against historical data. With capable processes, you can detect variations in performance and address potential problems early. Ultimately, you could be continuously improving the processes by identifying the root causes of process variability and finding innovative ways to make them better. That, in a nutshell, is how the CMMI works. Sounds pretty simple. Unfortunately, when you actually look at the model, the complexity of the framework becomes evident, and the way it is applied can become daunting. Let's delve a little deeper into the details of the architecture and use of CMMI. CMMI is really a suite of interrelated materials organized to be flexible, extensible, and consistent. At the top, there are constellations. Constellations are a packaged set including a model, training materials, and appraisal documents from the CMMI framework that cover an area of interest, such as development, services, or acquisition. Constellations provide a way for the CMMI to be used with as much commonality as possible for different types of organizations. The core of each constellation is the CMMI model created for its area of interest. The core of each model is the CMMI Model Foundation, a set of common material that is contained in every CMMI model. The essential building blocks of the model are goals and practices. These are the components that actually influence improvement. Now, they exist in several forms, but in general, goals are the desired state, and practices are ways to achieve that state. CMMI models are organized into process areas. Now, not everything related to processes and process improvement can be included in a process improvement model. CMMI selects only the most important topics for process improvement and then groups these topics into areas. The number of process areas varies with each constellation. Let's look at a process area, we'll call it a PA for short, and see what it covers. For our example, we'll use requirements management. Why do we have a requirements management PA? Within systems, software, and hardware engineering, it is widely believed that the management of the product requirements is a central area of concern during any development effort. Experience has demonstrated that failure to adequately identify requirements and manage changes to them is a major cause of projects not meeting their cost, schedule, or quality objectives. So, collecting information related to the management of requirements seems to make sense. So there is a requirements management process area, and you can use that process area to raise your capability to manage requirements. Now, as stated in the model, the purpose of the requirements management process area is to manage the requirements of the project's products and product components and to identify inconsistencies between those requirements and the project's plans and work products. The process area has specific goals that describe the results of a successful requirements management process, and each goal has specific practices that can help achieve it. Now, there's a great deal of explanatory and how-to material also supplied to provide more concrete help with managing requirements. Read through the goals and practices for requirements management and see what you think. Given all that information, how do you decide what to apply? You should focus on the goals, pure and simple. The sole required component of the CMMI models is the goal. A goal represents a desirable end state, the achievement of which indicates that a certain degree of product and process control has been achieved. When a goal is unique to a single process area, it's called a specific goal. In contrast, when a goal may apply across all of the process areas, it's called a generic goal. And we'll talk about generics a bit later. Each process area has between 1 and 4 specific goals. And that's pretty simple. There are PAs with goals and goals with practices for important things to do. So, you might ask, where does the improvement stuff come in? Well, to understand that, we need to look at two concepts that drive improvement: capability and maturity. We've mentioned these already, but let's look at them a little more carefully. At its core, capability is all about improving within a process area. It focuses on establishing baselines and measuring improvement results in each area individually, and is associated with continuous representations. In contrast, an organizational maturity perspective emphasizes sets of process areas that are intended to define proven stages of process maturity across an organization. This approach is employed generally in a staged representation. Now let's talk about those representations a little bit. We'll start with staged. When most people think of CMM or CMMI, they are thinking of a staged representation. The ubiquitous focus on organizations reaching level X is essentially looking at organizational maturity. A staged model provides a predefined roadmap for organizational improvement. The term staged comes from the way that the model describes this roadmap, namely as a series of stages that are called maturity levels. Each maturity level has a set of process areas that indicate where an organization should focus to improve its organizational process. Progress occurs by satisfying the goals of all process areas in a particular maturity level. Looking at the PAs for each level, you can see how the stages in CMMI work to mature the organization. Continuous models provide less specific guidance on the order in which improvement should be accomplished. These models are called continuous because they lack these discrete stages, and therefore have no concept of organizational maturity. Like staged models, continuous models have process areas that contain practices. Unlike staged models, however, the practices of a process area in a continuous model are organized in a manner that supports individual process area growth and improvement. Most of the practices associated with process improvement are generic. Generic in the sense that they are not specific to any one process area. They are external to the individual process areas and apply to all process areas. The generic practices are grouped into capability levels, each of which has a definition that is roughly equivalent to the definition of the maturity levels in a staged model, with an associated generic goal. Process areas are improved and institutionalized by implementing the generic practices in those process areas. Organizational improvement is represented by the collective capability levels of all process areas, referred to as a capability profile. An organization can tailor a profile to target only certain process areas for improvement. In other words, the organization can create its own staging of process areas. This diagram shows how capability is built using generic practices and generic goals. You can find a lot more detailed information about the process areas, their specific goals and specific practices, along with capability levels, generic goals, and generic practices in the CMMI distilled appendix provided in the class materials. Let me say a quick word about appraisals. They are a large part of CMMI improvement and should be used as a key part of a process improvement initiative. Appraisals are designed to provide a measure of the organization's improvement. It is appraisals that provide the hungered-after level number. There are several classes of appraisal, all of which have requirements that are formally documented as a standard CMMI approval method for process improvement, SCAMPI, or, for short, SCAMPI. I know, scampi are little small shrimp, or shrimp that have garlic and butter on them, or something like that. Now, there are a lot of jokes related to this particular acronym, and I'll probably post some at some point for you. My favorite one, though, is an observation, not really a joke. It says, if you take the process improvement, the PI, out of the appraisal rationale, all that's left is SCAM, or a scam, which for the non-US folks is the idiomatic word for swindle or cheat. So if you're not looking at an appraisal for doing process improvement, then you're sort of cheating and you're being cheated. We've looked at how CMMI is constructed and used. It's time now to look at CMMI, the good, the bad, and the ugly. First, the good. CMMI is well documented, has a deep pedigree, and was created by over 250 authors and reviewers. There is a broad international infrastructure of consultants, trainers, educators, and proponents. It has proven resilient to significant efforts to marginalize it. As these graphics all show, it has been extensively adopted with documented successes. While it's often described as a set of best practices, it may be best to think of CMMI and its goodness as a set of critical success factors without which organizations and projects can fail. It makes a very good risk register for developers and acquirers. Thirdly, CMMI integrates multiple disciplines in a way never before attempted. It has shown itself to be extensible and so provides a cross-discipline vocabulary and a common language for process improvement. All very good points. Now for the bad. CMMI is big, complex, and written in process improvement language. It's difficult to interpret because it's filled with overloaded and specially defined terms. So when you read it, you expect English, but you don't get English. You get a special version of English, which is specific to process improvement. A good example is the use of defined, as in a defined process. To a normal English-speaking person, a defined process would be one with a definition. However, in CMMI speak, a defined process is, according to the glossary, A managed process that is tailored from the organization's set of standard processes according to the organization's tailoring guidelines, has a maintained process description, and contributes work products, measures, and other process improvement information to the organizational process assets. See managed process. Wonder what a managed process is. Looking farther, we find that a managed process is a performed process that is... oh, never mind. You get the picture. Having multiple representations and models, while very flexible and of a great use to mature organizations, causes a good deal of confusion, particularly when dealing with upper management, who always seem to just want a number. This also makes CMMI very scary for newcomers in small environments. CMMI is also primarily focused on systems development. Its defined scope does not extend out into the enterprise, although the improvement concepts certainly should. Value and cost are not considered, and there is very little coverage of sustainment or non-product related activities. It is, by nature, internally focused, with little emphasis on the customer. Finally, it can be very expensive when used as directed by most of the traditional PI proponents. Setting up engineering process groups may work well in large organizations with a good deal of overhead available, but it doesn't really fit small, lean, agile groups very well. And now for the really ugly. From the last lecture, you will recall that process improvement got its start in manufacturing. Because of this, maturity has been defined primarily with respect to predictability rather than effectiveness. So if the foundations of the discipline are somewhat suspect, what are the odds that at some point it comes crumbling down? And speaking of foundations, it is a fact that CMMs started as a set of questions for the Air Force to check on to make sure their contractors were capable. So, for as long as capability maturity models have been around, there have been people interested in chasing levels, aiming to get appraised at some maturity with little or no regard to the improvement underneath it. Much of this is the fault of government and of other institutions that have used the attainment of a particular level as a de facto requirement to bid or win contracts. And finally, there are the true believers. As postmodern engineers, you would think we would be suspicious of persons who believed that there was only a single way to do any one thing. CMMI and process improvement in general have spawned numerous prophets who loudly proselytize for their pet approach. In fairness, this also occurs in development. Did you ever hear one of Kent Beck's early speeches on extreme programming? Hallelujah! In any event, when coupled with the obscure language of the models, this whole concept tends to breed a sort of priesthood that acts as an intermediary. The priesthood also tends to request fairly large offerings or prices for their true interpretations. Unfortunately, the orthodoxy of those interpretations can exclude organizations that don't necessarily fit the traditional mold, like lean and agile developers. Now, this priesthood effect is certainly not universal. There are a tremendous number of CMMI folks who feel as I do that CMM can be applied to a variety of organizations. But it may be best illustrated by an early redefinition of the acronym CMM by some of its creators as CMM, Consultant Money Machine. So what are we to take away from this little excursion into the CMMI process improvement world? Well, for one thing, a bit of skepticism, as well as some idea of the value of process improvement. CMMI can be a very, very good tool, but it's just that. It is not a silver bullet with which to kill Brooks werewolves. If we are creative, there are ways to use it as a high-power lead bullet, even without the PI infrastructure. Here are some of my ideas on how to use CMMI in different ways. First point. Ignore organizational maturity levels so that you don't get caught up in level chasing. Capability levels may be useful, but don't let them drive you. Your drivers should always be business objectives and aligning your activities with your organization's goals. Generic practices are your best friends. They drive improvement. Translate them into plain language and keep them with you. It's a handy checklist to keep for status meetings. Rewrite the process area specific goals into your organization's own language. Then map your existing processes to CMMI. That limits the number of people who need to know CMMI in depth. Use the model to manage the improvement initiative. Lead by example. We used this approach in writing the CMMI Survival Guide, and it is most apparent in the Part 4 material. Take a look at that. Integrate any of your process improvement activities with existing improvement initiatives such as Six Sigma or ISO. Use agile approaches to process improvement. For example, use short cycles to prototype process changes and maintain common ownership of the processes. The bottom line is, process improvement is not quantum physics. Anyone can do it. However, even though it can be valuable, actually implementing it can be extremely stressful. In the next lecture, we'll look at some ways to make sure you survive process efforts within your own project or organization.